Hello everyone. Today we are starting with subnetting. So in the last lectures, we saw that what is IP addressing, and then we saw different classes of IP addresses. Today we are starting with subnetting. Now what subnetting is, dividing a large network into smaller subnetworks is known as subnetting. So we are starting with subnetting of class C first. So we are starting with subnetting of class C. So if I'll write a network of class C, so it will be something like this: 192.16.0.0/24. That means this is the network ID, and these are the number of bits which are reserved for the network, right? So by looking at 24, you will come to know that you are going to get 256 IP addresses in total. If I will draw this, so it will be something like this. It will be something like this. That means we have started from 0 and we are going up to 255 and we are getting 256 IP addresses into this network, right? But let's suppose my requirement is only 100 IP addresses. I do not need 256 IP addresses. So what I will do in that particular case? So in that particular case, what I can do is I can divide this network into two parts. How you will divide this network into two parts? So this is a rule that you know it very well, that network part is not going to change. In class C, first 3 octets are reserved for the network and network part is not going to change. So if network part is not going to change, so what will change? So the host part will change. So you can see these are the host bits: 1, 2, 3, 4, 5, 6, 7, 8. So if you want to divide this network into two parts, what you have to do is you have to borrow one bit from the host to the network. As soon as you will borrow one bit, the network will be divided into two parts. So it will be something like this. It will start from 0, goes up to 127, starts from 128, goes up to 255, right? So this is going to be the. So what will be the value of this bit? The value of this bit is going to be 128. So that is why it is getting divided into two parts of 128, 128 each, right? So what is going to be network 1 in this particular case? So this complete network will be divided into two parts. So network 1, its network ID is going to be 192.16.0.0, which is written. Then the broadcast ID 192.16.0.127, and this is going to be /25 now. Why? Because earlier 24 bits were reserved for the network, now 25 bits are reserved for the network. Right? What is going to be the net mask now? So net mask is going to be 255, 255, 255. This was there earlier, now it is 128. And then the network 2. The network 2 is, the network ID for this network is 192.16.0.128. And what is going to the broadcast ID? Broadcast ID is going to be 192.16.0.255. So what is going to be the net mask? Net mask is going to be 255.255.255. Right? So your network will be divided into two parts, right? Now the next is, let's suppose you want to divide this network into two parts. So the formula says that if you will borrow one bit, network will be divided into two parts. If you will borrow 2 bits, network will be divided into 4 parts. If you will borrow 3 bits, network will be divided into 8 parts. 4 bits, 16 parts. 5 bits, 32 parts, and 6 bits, 64 parts. So class C network cannot be divided more than, class C network cannot be divided more than 64 parts, right? So in this particular case, you can see that if I will borrow 2 bits, the 4 parts will be 0 to 63, 64 to 127, 128 to 191, and 192 to 255, right? So this is about class C subnetting. Now let's see class D subnetting. If you want to subnet a network of class B, So let's suppose I am taking a subnet which is 172.168.0.0/16. This is going to be the default value. So if I will borrow one bit from the host to the network, network will be divided into two parts. So network one, which will be created, its network ID will be 172.168.0.0. It is clearly written. Its broadcast ID is going to be 172.168.127.255. And this will become /17 because we have already borrowed a bit, right? What is going to be the net mask in this particular case? So net mask is going to be 255.255. We were having it earlier, now 128.0. Then the network 2. So network 2, which will be created, its network ID is going to be 172.168.128.0. Broadcast ID is going to be 172.168.255.255, the last IP. And what is going to be net mask? Net mask will remain the same, which is going to be 255, 255, 128.0, right? And this is again going to be /17. So these are two networks, and in every network you are going to get somewhere about 32,000 IP addresses, right? So total was 65,536, and these are half of it, half, right? So that was about class B subnetting. Now we'll talk about class A subnetting. Subnet of class A will be, so let's suppose I am having 11.0.0.0/8. So if I will borrow one bit from the host to the network, so the network one will get created. Its network ID is going to be 11.0.0.0. What is going to be its broadcast ID? Its broadcast ID is going to be 11.127.255.255. What is going to be the net mask? So net mask is going to be 255.128 because we have already borrowed a bit, right? And this value is going to be /9 now. What will be network 2? The network 2 network ID is going to be 11.128.0.0/9. What is going to be its broadcast ID? 11.255.255.255, the last IP address. And what is going to be its net mask? Net mask is going to be 255.128.0. Right. So that was about class A subnetting. Now we need to see that let's suppose a network is given to you, and let's suppose the network is given to you, which is 192.168.10.0/28. If this kind of network is given to you, you need to find out three things into it. First is the network ID, second is the broadcast ID, and the third is the total number of IP addresses into this network, right? So network ID is written in front of you, right? So network ID is written in front of you. It is 192.168.10.0. Now broadcast ID we can find out only when we will find out the number of IP addresses, right? So total number of IP addresses, that is the formula, 2 to the power 32 is total minus 2 to the power 28, which is the result for the network. So what is remaining? 2 to the power 4 is remaining. 2 to the power 4 is equal to 16. So this is going to be, the broadcast ID is going to be 192.168.10.15, 0 to 15, 16 values. So likewise, we can find out network ID, broadcast ID, and the number of IP addresses. So in the next lecture, we'll see few examples where we will see that if you need to divide a large network depending upon the customer requirement, or let's suppose you need to subnet it according to different departments in an organization. So how you will subnet a large network into smaller subnetworks. So right now we have created these subnets which are of equal sizes, but you can also create subnets which are of different sizes, right?